Okay, good morning everybody. Today 9th of January, Friday. Okay, so we will carry on with our topic 3, okay, which is quite an important topic for you because it's going to be one question, okay, for the exam. Alright, so okay gentlemen, mind please, thanks. Okay. Yeah, so I think the key for this topic is firstly to be able to interpret the data sheet. Okay, but of course in the exam, right, you will not be given the whole piece of data sheet like this. They just give you a table, a small table with the various values. For example, the BOL, BIH, those kind of stuff. Okay, so you can take a look at your data sheet. If you look on the second page, I think, okay, you have all the different values. Alright, okay, which is given on the first page actually. First, the one with the operating conditions, right? The electrical characteristics. This one, yeah, right. This data sheet, right? Okay, is mainly this is the 74LS00. This data sheet, okay. So you can see that mainly is about the electrical characteristics of the IC that we are interested in. So if you look at the table under the electrical characteristics, you will see various parameters like the voltage, the current, and so on, right? Okay, so then later on in the lecture, we will just cover also on the switching characteristics. When you see things like the propagation delay time at the smaller table below, switching characteristics. Okay, we'll just have a quick look at that as well. Alright, so hang on to that first. Okay, so what I plan to do is, okay, I would use the survival guide there to help us. It will be quicker. I will go through the survival guide, okay, and then explain to you some of the contents there. Okay, so if you can you please turn to your survival guide page 2. Page 2 very quickly. Yep, you can get extra papers from here. Okay, so survival guide page 2. Okay, so we talk about two main types of the IC family. The two main ones. Okay, for the two main types of IC, right? We always be talking about TTL. Okay, TTL family. TTL stands for transistor logic. Okay, the other one is the MOSFET. Okay, so these are the two major families in the IC world, TTL and MOSFET. Okay, but for this course, this module, right, you'll be focusing more on the TTL, transistor logic. So in a nutshell, right? So, okay, if you see a gate like this, what is this gate? So you all know very well, right? NAND gate. Now what this NAND gate, what you don't see, or unless you have a microscopic eye, then you can see what's inside, right? You got a big microscope, then you can see what is actually inside. It's made up of many transistors inside. So they look like structures. IP transistor. Okay, my drawing doesn't look like cockroach. It's actually a lot of transistors, okay, inside this gate itself. You understand? So how it works, okay, we will come to that. Okay, very briefly. Okay, so moving on to page 3, can you turn to your page 3 of your survival guide? I have it in a handout form, but it's inside your notes, page 3. Okay, you will notice that in the last lesson we talked about two things, right? One is current sourcing, okay, and the other one is sinking. Okay, when you current source or you current sink, it has two different meanings. Right? So sourcing, right? Sourcing is done by the driver. Okay, in order to source current means you supply. Okay, source means supply, right? You supply current. Sinking means you receive it. So usually the person who the device who receive it is usually the load. Okay, another gate, for example. So for example over here, my NAND gate, right? Okay, this NAND gate, perhaps I call him a driver. Okay, maybe this NAND gate will drive 2 loads. Okay, maybe 2 inverters, for example. Okay, so if I were to segregate them, these 2 are the loads. Okay, this one is the driver. Okay, so you have the driver and the load. Okay, so here will be sourcing. It will be sourcing or source. This one will sink. Okay, if you are supplying current in a way, right? You supply current, right? Okay, depending if your here is high state, logic high, then you can be supplying, right? Okay. So you can refer to your notes. Refer to your notes. Okay. So it is important then to determine in the next part is to determine, for example, if you have certain connections of gates. Okay. How do we know this NAND gate? How many loads can it drive? You know what I mean? That's the next part. Let's say if I told you this one can drive 50, but is it really 50? How do I know? Is there a way to quantify this or calculate this? Okay, how do I know? What is the number? Is it N? I don't know, right? The way to calculate this one is to calculate this thing called a fan out. Okay, fan out. Fan out means is you are trying to calculate, okay, how many gates how many loop gates the driver supply. Okay, so fan out got 2 types. In the last lesson, we also briefly discussed, right? Okay, so I'm moving to the next few pages, which is okay. I'm going to skip a few. Yeah, and I'm going to turn to page 7. Of the survival guide, okay, which I just explained. Current sourcing, current sinking action. Okay, you can see the illustration on the picture. I'll point it to the camera here. Okay, page 7. Right, so you can see that when you are sourcing, right, just as I explained earlier, you drive the current this direction. Okay, sinking. The case where sinking could be that the output here is low. Okay, this one can also go low state. Okay, if it's low, then you have a backflow of current going back to the driver. Okay, I think it's quite clearly illustrated this picture. Yeah, but I don't know why the 2 picture of the Merlion sits there. Probably the water jet flowing out. Mr. Bernard's idea. Okay, but I think you roughly get an idea. Okay, so you have the current sourcing and current sinking. Yep, okay. Can you turn to the next page, page 8? Okay, page 8 then discuss about fan out. Okay, discusses about this thing called fan out. Okay, or loading factor. Usually they call it fan out in the exam. If they ask you calculate the fan out. Okay, so you can see a picture, right? A picture of this motorbike. Wow, see your family of so many kids. And the cute one is the one in the little bucket. Amazing. This is real. Okay, right, see this picture, right? Okay, so how many passengers can you carry? Okay, or how many gates can you drive? That's the idea. Okay, fan out. So fan out is defined as the stuff in the box there. It says what? It's the maximum, right? Maximum number of logic inputs, okay, that an output can drive. Okay, but you must add one more word: reliably. Okay. You must be able to drive reliably. Okay, this one, maybe you can add one more word. Okay, you must be able to drive reliably. Okay, you can add one more word at the back. Okay, so if I tell you a driver can drive 20 gates, that means the fan out is 20, for example. Okay, that means I can drive 20 gates. If this guy can drive 50, then this one has a good fan out. He can drive 50 gates.
Why you put a low there?
Huh? No, because here, this state, just to clarify, this output here, a NAND gate can be high or low, right? Right now, this output here, because the NAND gate logic, you know, right? The output here can be high or low. So that's why I put low or high. I'm referring to the logic. Okay, the logic state. High state or low state.
Then the source is?
Source is when it's driving. That means when it's in the high state, then it's your sourcing current. You get what I mean? Okay, maybe to clarify, when it's in the low state, you're sinking. So I shouldn't put the sink here really. Okay, sink should be here. Okay, when it's in the high state, you can refer back to just now your notes.
The high state is sourcing. Right?
Yes, correct. When it's high means your logic high, 5 volts let's say, you are supplying current. Voltage, remember potential difference, right? High potential to low potential, right? So you are supplying current. Kind of like your circuit, remember your circuit? Okay, you have plus 5 volt, then you have ground. The current will flow from plus to the ground. So sourcing that direction. Okay, when it's high state, you source, you supply. Okay, but when it's low, low is means zero, man. Yes, correct. If it goes back, you draw some current from the outside. Okay, but this one is actually shown in just now the page 7. You saw the page 7, the one, right? They show you the flow of the direction of the current. Okay, page 7.
So I means is source is
Yes, source, supply.
When it's low means
Sink.
sink means current is coming back.
Yes, correct. Shown here.
Means I means is losing current, is it?
Yes, correct. It's supplying a voltage.
Means it loses current.
It supplies current. Okay. Morning, sir. Okay. Now, so okay, so basically, fan out is this. Okay, calculation of fan out is very critical. Okay, for your level, Okay, how to calculate fan out? Okay, that's the main gist of this thing. Okay, so you can look at. Okay, so very quickly. Okay, now so what happened is this. Now if you look at page 9, okay, look at page 9 of your survival guide. Page 9 survival guide. Okay, so what they are trying to do is a simple question there. Okay, asking you how many of these, you read the question, how many of these 74LS00 gate inputs can this same gate drive? Okay, so can you refer to your data sheet? You know, this data sheet that you've just given to you? Huh? Which one? You mean the input? Oh, you mean this? No. You just consider one only. You mean the other terminal, is it? The other terminal is connected to something else. Okay. So if you look at it, right, I mean you can look at the page, okay, so basically they draw a gate, right, so you can see that, okay, just a sketch, there's a couple of these gates here. Now what they are trying to show you is that you'll be able to identify which current to use, that's the main thing. Okay, this one you must know. Okay, so for example, okay, when you need to calculate two state, fan out. Fan out got two state, right? When it's high state, so the low state. Because here, start here, right? This part can be high, can be low. Remember, high or low, right? So you need to consider the two different conditions. So when it's high or low, right? So you have to pull out the correct values from the table. So for the case when it's low, okay, for the case when it's low, you are sinking. Right? Sink, when it's low state. Okay, you sink, right? So you are using the output when it's low for this gate, this logic gate. So you need to find out what is IOL. Okay, now it will be given to you in the exam. So, and also when the input is low, so right? Yeah, IIL. So you need these two parameters. Okay, and then of course you take the IOL max. What you do, right? You will find out what is the fan out. Because it's low state, okay? Because it's low, you will take from the data sheet the maximum value of this. Okay, divide by this one. Okay, refer to your notes on page 9, your survival guide. Okay, so with that,
it's always output over input.
Yes, absolutely. Okay, now notice that I also mentioned in the last lesson that because you're taking a current divided by a current, right? Yeah, this is supposed to be units of milliamp, let's say. So basically, it could be micro, so you gotta watch out. So, but anyway, ampere divided by ampere is gone. You know what I mean? You cancel off the units. So you end up with a nice number. Usually, okay, just a number, no units, right? So it means it's the quantity.
So it's not possible for the output to be. So it's not possible for the input to be bigger than the output.
Not possible. If you get a funny value, something is wrong. What's just to how to say? Give you a pointer. Okay, if you get some funny numbers like this, something is wrong because fan out is a number. Greater than, cannot be 0.
Why is 18 point something?
Huh? Then you round up.
Sure.
Round up or round down?
Round up.
So I still why you use
So
max?
it is
IOL max.
18.2
Why do you use IOL
I don't know.
minimum?
Because it's the output current. Output, this is going to the output. This is the output. Output terminal. This is the input terminal. That's why it's input current.
Okay, why use maximum?
Huh?
Why do you use
You have to
maximum?
consider the worst case.
But when do you use minimum then?
Huh?
When do you use minimum then? You won't use it. You won't use it at all.
You use
No, you
maximum.
need to consider both, maximum and minimum.
Huh?
We have to consider high.
High or low is the next one. I haven't do yet. The fan out when it's high state.
Oh, okay.
Then I'll be showing the low state first.
So 18.2 also 19.
Same.
18.2, then 18 as usual lah. You
No,
round
it's round up or round down.
okay, as usual lah. What you all learn above 0.5 then you round okay. Okay, so if you get something like this, something funny, then please check. This one wrong. Okay, should be a nice number. So the case here, your actual one, right, is 8, right? 8 milliampere divided by 0.1. Right, 8 milliamp, 0.1 milliamp. Answer is 80. But this is not the answer yet. Remember, this is not the final answer because I haven't considered the other state. Yes, the high state. So which therefore leads me to the next page, on page 10 of the survival guide. Okay, for the next one, the fan out when it's in the high state. Okay, fan out on the high state. Okay, fan out high. Okay, for fan out high, you will take the out IOH max. Okay, this one standard one, this is standard, okay? Now I tell you initially for students, they get very confused, especially with those subscripts. OH lah, IH lah, VH, IH, okay, slowly, okay? Go slow on this one. Okay, now VOH, remember, OH means output when it's in the high state. Here's the output, output, right? When it's in the high state, that's why it's called IOH, output when it's high. This IOH refers to this point here, this one. Okay? Then IIH means is the input when it's high. So input refers to this one here, this point. This one going into the input gate. Okay, so you do this. So you have to pull out the information from the table. Okay, from the table. So you can see where is IOH. Okay, IOH.
Oh, yeah. This one is it.
Yeah.
Minus 0.4.
So you get 400 IOH, the maximum value.
Which are
Forget,
the negative value?
ignore the negative side, don't care about the negative side. Just take the one at the top. You all know where to find it? Can you all identify the value from here? So there's a negative sign, right? This one. Is it your table is on the first table? 1, 2, 3, 4, 5. Fifth row. Fifth row. 1, 2, 3, 4, 5. Fifth row, fifth column. You see minus 0.4. Am I right? Yeah, minus 0.4. You ignore the negative sign. Okay? You just yep, 0.4, correct. So it's 400 microampere. Divide by the IIH. Okay? Which is 20.
So you mean we need to keep looking at the data sheet every time we do this?
Yeah. The whole idea is that they will give you some table, but not so elaborate lah. You know what I'm saying? The table is not so.
This is to identify the high and low state.
Correct. They will give you.
But the question won't say it's in the data sheet.
They won't tell you. They just give you this table. You just pull out the value.
IIL, right? But the data sheet is negative 0.36. Why we use it? The data sheet IIL is negative 0.36.
Right.
Electrical characteristic.
IIH, okay, fine.
IIL.
The previous one.
Then why they use Y? Then why they use IIL?
Next, IIL. The what? 21, right?
IIL is negative. We use II. Oh, they use II. They just use II.
But 0.1, right? That one.
1.1, but the IIL is negative.
Okay, I check for you. But I think you get the general idea first.
Yeah,
Yeah. Okay.
later use wrong then.
I'll check for you.
Why is it negative?
Huh?
Why is it negative?
Direction problem.
Direction.
But it's high. The height to be doing the normal side.
No, I think you just take it as a polarity, but in your calculation, you take all absolute value. Okay? Just ignore the negative sign. But I think for the time being, okay, I think general idea is quite clear. Okay, except that maybe some value will clarify with that one. Okay? So, but the main thing, we'll come to that. Okay, but the main thing is that after you compute this, right? Okay, you get two values, right? So which one do you take?
The lower
The lower one, yes. Okay, remember, always choose the smaller one.
Why, sir?
Smaller of the two. Okay, of the two.
So you choose from here.
Remember, it's not important.
It's an engineer thing, Sarah.
Yes, it's an engineering thing.
So that means I can
Choose
still
the
do
worst
this.
case.
Yeah, ask you a question. Yes, I don't need to even fan out low. I can immediately go to do fan out high. Right?
Cannot. You don't know which one until you calculate. You know what I mean? So you will choose the lower one.
Because there's a possibility that the
Yes.
lower will still be.
Yes, right. So you cannot assume, you need to show the working. Work out both, okay, and then choose the smaller one. Then you're safe. Because the smaller one, right, if you choose the smaller one, your high one also you can take. So will work. But the small one is safe. So that means when I design, right, I will choose up to 20 gates. I'll do up to 20. I won't go up to maximum because I will spoil.
It depends on the customer.
Alright.
IL maximum.
And maybe we try later on some sample question.
Ada dua.
Okay, any question?
Oh.